So this is lessons 14 and 15. Lesson 14 will continue talking about absolute value functions that we started doing yesterday. And lesson 15 will introduce inverse functions. So the first problem says the absolute value function can be defined using piecewise notation. Use this notation to find the following values. So number 1 says a of 10. So 10 is in parentheses, therefore 10 is our x value. 10 would fall under the greater than or equal to 0 rule. Therefore, the function equals x, and x is 10. So a of 10 equals 10. Number 2, a of 0. We're saying 0 is our x. This would fall under the top rule. 0 is greater than or equal to 0. Therefore, the function a of 0 equals x, and we said x is 0. Number 3, we have a of negative 3. Negative 3 is x, therefore we follow the bottom rule because negative 3 is less than 0. That means a of negative 3 equals negative x, so negative 3 would be positive 3. Number 4, a of 3.14159. This is pi. 3.14159 is x. It follows the top rule because that is greater than or equal to 0. Therefore, a of 3.14159 is going to equal x, so it equals 3.14159. Number 5, this time they don't give us x, they give us what the function equals, and it says it equals 7. Well, if this followed the top rule, then 7 would be x, and 7 is greater than or equal to 0. So, because 7 is greater than or equal to 0, x could equal 7. But if this 7 represents the bottom, which is negative x, then that means x is less than 0. So if x were negative 7, negative 7 is less than 0, so x would equal negative 7. So both of those values of x would give you 7 as the value of the function. And then number 6, they tell us the function equals negative 5. Well, if we look at the top rule, that would mean x equals -5 and x is greater than or equal to 0, which is not true. -5 is not greater than or equal to 0, so that can't be true. And if we follow the bottom, -5 being x, -5 would be +5, and that would say that +5 is less than 0, which is also not true. So 6 has no solution. Here are 4 equations of absolute value functions and 3 coordinate pairs. Each coordinate pair represents the vertex of the graph of an absolute value function. Match the equation of each function with the coordinates of the vertex of its graph. The vertex coordinates of the graph of one equation are not shown. So the first choice we have is -9, 0. This means if we substitute -9 in for x, our answer would need to be 0. So if we look at A, -9 minus -9 or -9 would be -18, and the absolute value would be 18, not 0. So let's look at B. The absolute value of -9 would be 9, and 9 plus 9 is 18, not 0. Move on to C. -9 plus 9 would be 0, and the absolute value of 0 would be 0. So this one, the absolute value of -9 plus 9 equals the absolute value of 0, which equals 0, and matches choice 1. Number 2, we have 9 for x and 0 for y. If we try A, 9 minus 9 is 0, and the absolute value of 0 is 0. So this matches. Absolute value of 9 minus 9 equals the absolute value of 0, which equals 0, and matches number 2. And finally, number 3, we have 0 for x and -9 for y. If we look at B, the absolute value of 0 is 0, and 0 plus 9 is 9. That doesn't match. If we look at D, the absolute value of 0 is 0, and 0 minus 9 is -9, which is what we want. So absolute value of 0 minus 9 equals 0 minus 9, which equals -9. So D matches 3. Function G is the general absolute value function. So this will be a V-shaped graph with its vertex at the origin. 0, 0. Function R is this V-shaped graph from G, but the plus 2 means the Y values will be 2 larger. So this V-shaped graph shifted up 2 units to a vertex of 0, 2. So if you have the plus 2 outside of the absolute value brackets, it shifts the V-shaped graph up 2 units. Here is the graph of a function. Select the equation for the function represented by the graph. So if you notice, we have a graph with its vertex at 0, -5. So if we put 0 in here, we would have absolute value of 0 minus 5 equals 0 minus 5, which equals -5. That's what our Y value is. So A is the correct equation. If we tried the same thing with the others, we would have absolute value of 0 plus 5 equals 0 plus 5 equals 5, which does not match. For C, we would have the absolute value of 0 minus 5, which would be the absolute value of -5, which equals 5 and does not match. And D, we would have the absolute value of 0 plus 5, which equals the absolute value of 5, which equals 5, and also does not match. The temperature was recorded at several times during the day. Function T gives the temperature in degrees Fahrenheit n hours since midnight. Here is a graph for this function. Number 1, pick 2 consecutive points and connect them with a line segment. So I will choose this point at x equals 11, and I will connect it with the point at x equals 12. Estimate the slope of that line. Well, it looks like the second point is at y equals 61, and the first point is at y equals 55. And it looks like our second point is at x equals 12. And the first point is at x equals 11. So 61 minus 55 is 6. 12 minus 11 is 1. So the slope is 6 degrees Fahrenheit per hour increase. Number 2, pick 2 non-consecutive points and connect them with a line segment. Estimate the slope of that line. Explain what that estimated value means in this situation. So I will connect the point at x equals 14 and the point at x equals 19. The slope here, my second y value appears to be 66, and my first y value also appears to be 66. My second x value appears to be 19, and my first x value appears to be 14. 66 minus 66 is 0. 19 minus 14 is 5. And 0 divided by 5 is 0. In this situation, it means the temperature was the same at 1400, which is 2 p.m., as it was at 1900, which is 7 p.m. A tennis ball is dropped from an initial height of 30 feet. It bounces 5 times, with each bounce height being about 2/3 of the height of the previous bounce. Sketch a graph that models the height of the ball over time. Be sure to label the axis. So my y would be my height in feet. And I'm going to increase this by 10 feet each marker. And this is over time, and it makes sense to use seconds if we're talking about a ball bouncing. So we know that the ball is going to start at 30 feet. So we could put our first point on the y-axis at 30 feet. We know this ball is going to fall and it's going to hit the ground. Maybe we say 2 seconds. Now when it bounces, it's only going to bounce 2/3 of that. So 30 times 2/3. 3 goes into 30 10 times. 3 goes into 3 once. So this equals 10 times 2 is 20. So my next point needs to be at 20. And then it's going to come back down and hit the ground again. So my second bounce is going to be 20 times 2/3. 20 times 2/3 is going to be 40 over 3, which equals 13 1/3. So my next point should be about 13 1/3. And then it'll come and hit the ground again. So now my third bounce is 13 1/3 times 2/3. So that's about 8.8. So when I make my third bounce, I'm going to say it's about 8.8. And then it's going to come back down and hit the ground again, where it will bounce for a fourth time. 8.8 times 2/3. Is about 5.8. So that's where we'll put our fourth bounce. It'll hit the ground and bounce a fifth time. 5.8 times 2/3 is approximately 3.8. So we'll put our last point for the bounce there, and then we'll say it hits the ground and it rolls to a stop. So now we see the ball come down, hit the ground, bounce once, hit the ground, bounce twice, hit the ground, bounce 3 times, hit the ground, bounce a fourth time, hit the ground, bounce the 5th time, hit the ground, and then roll to a stop. And this is how we could graph this word problem. This is the last practice problem for lesson 14. Here are two graphs representing functions f and g. Identify at least two values of x at which the inequality g of x is greater than f of x is true. G of x is the top line. So if I want g of x to be greater, that means I want the y value of g of x to be greater. So anywhere between here, where they cross, and here, where they cross. So now I look for values, and I could say right here when x equals 0, and I could say right here where x equals 2. Both of these values of x make g of x greater than f of x. Noah's cousin is exactly 7 years younger than Noah. Let C represent Noah's cousin's age and N represent Noah's age. Ages are measured in years. Number 1, write a function that defines the cousin's age as a function of Noah's age. What are the input and output of this function? So if I want a function that defines the cousin's age, then I want C equals. The cousin is exactly 7 years younger than Noah. That means I have to take Noah's age and subtract 7 years. In this equation, we use Noah's age as the input and the cousin's age is the output. Number 2, write the inverse of the function you wrote. What are the input and output of this inverse function? The inverse means I want to solve for the opposite variable. So now I don't want to solve for the cousin's age. I want to solve for Noah's age. To do this, I'm going to take the original equation and I'm going to move this 7 to the other side. So now I have an equation that says C plus 7 equals N. So the inverse function solves for Noah's age using the cousin's age as the input and adding 7 years to it. So now cousin's age is the input and Noah's age is the output. So the inverse function solves for the opposite variable. Noah's cousin is exactly 7 years younger than Noah. Let M represent Noah's cousin's age in months and N represent Noah's age in years. If Noah is 15 years old, how old is his cousin in months? So we want to find his cousin's age in months. So that's M. So that's going to be Noah's age, which is 15 years old, but we want that in months. So we need to multiply that times 12. And then we need to subtract 7 years, but we need that in months. So we're going to multiply by 12. 15 times 12 minus 7 times 12 equals 8 times 12. We subtract the 15 minus the 7 to get the 8, and both of those numbers were being multiplied by 12, so we leave 12 in parentheses. Now 8 times 12 is 96, and that's 96 months. Number 2. When Noah's cousin is 132 months old, how old is Noah in years? So now we want to find Noah's age in years. So that's going to be the cousin's age, which is 132 months. But we want the months converted to years, so we're going to divide by 12. And then we need to add the 7 years difference. So now 132 divided by 12 equals 11 years, plus the 7 years that Noah is older than his cousin, tells us that Noah is 18 years old. Number 3, write a function that gives the age of Noah's cousin in months. So we want m equals as a function of Noah's age in years. So we would take Noah's age in years times 12 minus the 7-year difference times 12 months. Number 4, write the inverse of the function you wrote. What are the input and the output of the inverse function? So now, instead of m equals, I want Noah's age in years equals his cousin's age in months divided by 12 months plus 7 years. And in this inverse function, we have the cousin's age in months is the input, and n, Noah's age in years, equals the output. To go from the equation in 3 to the equation in 4, both of these are multiplied by 12. So I could rewrite this as m equals 12 times n minus 7. Then I would divide both sides by 12. And this becomes m divided by 12 equals n minus 7. Then I just add 7 to both sides. And we end up with n equals m divided by 12 plus 7, which is what I wrote for number 4. Each equation represents a function. For each, find the inverse function. So for number 1, I want to change from an equation that solves for C to an equation that solves for W. So I'm going to subtract 3 from both sides, and now I have W equals C minus 3. Next, number 2, instead of an equation that solves for y, I want an equation that solves for x. So I'm going to add 2 to both sides. Now I have an equation that says x equals y plus 2. For number 3, instead of y equals 5x, I want an equation that says x equals. I divide both sides by 5, and I get x equals y over 5. And for number 4, instead of an equation that solves for w, I want an equation that solves for d. So I'm going to multiply both sides by 7. The 7's cancel out on the right. So now I have an equation that says d equals 7w. So once again, the inverse function solves for the opposite variable. The number of years y is a function of the number of months m. The number of months m is also a function of the number of years y. Number 1, write 2 equations, one to represent each function. So first off, the number of years y is a function of the number of months. This means we want y equals, we would need to take the number of months and divide that by 12 to get the number of years, because there's 12 months in a year. Now, the other one, the number of months equals 12 months times the number of years. Number 2, explain why the 2 functions are inverses. Well, if you look at the first one, months is our input, and years is our output. But when you look at the second one, now years is my input and months is my output. They are inverses because the inputs and outputs are opposites. This is what it means to be an inverse. If you think about it, if we take a graph and we turn it on its side and we change our x to become our y and our y to become our x, that's exactly what we're doing here with the inverses. Sketch a graph to represent each quantity described as a function of time. Be sure to label the vertical axis. So in the first one, we're talking about a swing. The height of your feet above ground while swinging on a swing at a playground. So if we're looking at height, then our y-axis is going to be height. If I'm on a swing, then my feet are dangling. So I don't want to start down at the origin. I want to start a little bit above it. From here, I'm going to go up as I go out to the front. Then I'm going to come back down again to the middle. And then I'll go up as I'm going to the back. And then I'll come down again as I near the middle. So this is what a graph would look like if we were comparing height above the ground and time on a swing. For the second one, we're talking about a slide. We're following the height of your shoes above the ground as you walk to a slide, go up to a ladder, and then go down a slide. So my shoes are going to start out on the ground, and as I walk, they're on the ground. One is being picked up, but the other one is staying on the ground. Then I start to climb the ladder, up the slide, and then once I get to the top, I'm going to slide down until I get back to the ground. So this is what the graph could look like if we're talking about a slide and tracking the height of the shoes as we walk to a slide, go up a ladder, and then down a slide. The third one is talking about a merry-go-round. We're tracking your distance from the center of a merry-go-round as you ride the merry-go-round. So we want to label the y-axis as distance from center. And I need to go back and label the y-axis on the previous one. We were tracking height. Okay. So now back to the merry-go-round. Your distance from the center as you ride a merry-go-round, well, you don't really move when you're on a merry-go-round. You get on it, you sit or you stand, and while it spins around and around, you are not getting any farther or closer from or to the center. So we would just pick a distance, and that distance would stay the same the entire time. And finally, number 4 here, we're talking about a merry-go-round again, but this time we're tracking your distance from your friend who is standing next to the merry-go-round as you go around. So this time when we label our y-axis, it's going to be distance from friend. And maybe we start out right next to our friend, and as the merry-go-round goes in circles, we're going to get away from our friend and then come back to our friend. And then we go around and away from our friend and we come back to our friend. And this repeats. So these are 4 examples of how you can turn a description of a situation into a graph on a coordinate plane. Lynn charges $5.50 per hour to babysit. The amount of money earned in dollars is a function of the number of hours that she babysits. Which of the following inputs is impossible for this function? So always remember your keywords. Is a function of. The very next thing that follows is your input. So my input is number of hours that she babysits. Well, if we think about this, can you babysit 2 hours? Yes. Can you babysit 5 hours? Yes. Can you even babysit 8 hours? Yes. Is it possible to babysit -1 hours? No. A is the impossible choice for the input because it's talking about time spent babysitting, and you can't spend negative time babysitting. The instructions for cooking a steak with a pressure cooker can be represented with this set of rules, where X represents the weight of a steak in ounces and F of X the cooking time in minutes. Describe the instructions in words so that they can be followed by someone using the pressure cooker. So if we look at the top rule, X represents the weight of a steak in ounces. So this top rule says for a steak between 8 ounces and 12 ounces, you cook it for 7 minutes. Then if you look at the other rules, each rule going down adds 1 ounce to the weight of the steak. And we see that the value adds 1 extra minute. So we would say for each additional ounce, cook for 1 additional minute. And now they want us to graph the function. So our first rule the values of x are 8 to 12, both included, and the y value is 7. So we go over to x equals 8, and we go up to y equals 7, and we put a solid dot. Then we go over to x equals 12, up to y equals 7, and we put another solid dot. And then we draw the line that connects them. The next rule is from 12 not included to 13 included. And the value is 8. Then we go up another minute, a hollow dot, then a solid dot, and the line connecting them. We go up. We have a hollow dot because it's not included, a solid dot at 15 because it is included, and the line connecting them. And the final rule, 15 is not included, 16 is included, and we draw the line connecting them. So everywhere we are not including the x value because it is only a less than symbol, we use a hollow dot. Anywhere we are including that x value because it's less than or equal to, we make that dot solid, and then we draw the line connecting them. And this would be the graph for this situation. The absolute value function q of x equals the absolute value of x gives the distance from 0 of the point x on the number line. Q can also be defined using piecewise notation. Q of x equals x when x is greater than or equal to 0. But Q of x equals negative x when x is less than 0. Determine if each point is on the graph of Q. For each point that you believe is not on the graph of Q, change the output coordinate so that the point is on the graph of Q. So for number 1, our x value is negative 3. When x is less than 0, our y value is negative x. So this would be negative 3, which equals 3. That matches our y value, so yes on graph. Now we'll try the same thing with number 2. In number 2, x is 0. That follows the top rule, x is greater than or equal to 0. When this is the case, then the function, or y, equals x. So that means 0 equals 0. That matches the y value, so yes on graph. Now we'll try number 3. In this case, x is negative 5. This would follow the bottom rule because x is less than 0. When that's the case, the y value is negative x. So negative 5 equals positive 5. That does not match the y value we have, so we would need to change this from negative 5 to positive 5. Number 4. The x value is negative 72. This would follow the bottom rule when x is less than 0, y, or the function, equals negative x. So negative 72 equals 72, which matches the y value we have. So yes, this one is on the graph. And finally, number 5, we have an x value of 4 over 5. This would follow the top rule because x is greater than or equal to 0. This means y, or the function, should equal x. That means 4/5 should be 4/5. That does not match the y value we have, so we need to change that to be 4/5. These are all the practice problems for lessons 14 and 15. If you still have any questions about absolute value functions or about inverse functions, please use class time to ask for clarification before the end of Unit 4 test, which is scheduled to be Monday, February 12th.